Hi and welcome back to the Low-Level Devel channel's Build a Linux Distribution from Scratch series. In the previous video, we set up our initial build environment so we can start building our packages without having any dependencies on the host system. In this next video, I'll start discussing the structure of our packages, how we'll build them, and how they will be packaged and installed. And we'll start developing a simple program in C to assist in creating our packages. I'll separate this into 3 separate videos so that the videos don't get too long and hard to follow. So let's get started. Okay, first I'm going to set up some directories here. So we're in our LLD Linux dist folder, which is the Git package that we created. So I'm going to make a directory for source, and then cd into there, and I'll make a couple of directories here. Let's say include. We'll also make, should do common, and then one for SPKM, that's Simple Package Manager. Alright, and now let's open the Visual Studio Code here. Actually, I already have it open. Alright, so now in our Simple Package Manager, include and common, they're all under source. So first, to start off, let's go back and we'll look at how these packages are set up. Let's start with this installing basic software. So let's pick one of these like glibc. This one is pretty complicated, so this is a good one to start with. So these are all the build commands, your configure, your make, and if you want to test, there's a make check as well, which I'd recommend you doing, but I'm not going to do them in here just for brevity. So make, install, and then there's a bunch of stuff you have to do after you've installed it. So running localdef, let's see, creating an NS switch configuration. So these are all things that run after you've already installed it. So we need a script to be able to install these as a part of our installation process as well. TZ select, that selects your time zone. So I'll run through this once we set up a structure. So let me clear. So I'm going to go back and we're going to create a folder for our repositories. So I'm going to make dir repo. So this is going to be the base of the repository for all our packages, all the stuff that describes how to build and install packages. And what we're going to do, let me scroll up here to go up one. Alright, let's go back to glibc. So what we're going to do is use a directory structure where we take this the first letter of a package followed by the name of the package, so that we don't have too many directories in one directory. So we're going to make dir g and then make dir g/glibc. So anything that starts with G will be under the G folder and then have its own subfolder under there. That'll make it easier to see them and Git and all that. So I'm going to create a couple of files, a .pck file. It's going to have the description of the package, a .build file which will have scripts to do the building, a .install directory, and a .install/install.sh. Now those last two won't be in every package. They'll only be in packages that actually have some stuff that we need to do after we actually install the files and everything. So this PCK will be the important one because that's going to describe what the structure is. So this install.sh is what will run after we actually move the files to where they're supposed to be. So let's look here. They all look in the right place. Alright, let's start, and this is what the structure is going to be. I'm going to use YAML, so it's going to have, which is just like an XML, it's yet another markup language. So we're going to have different fields, name, version, repo, and the repo is going to be core, because eventually we might have more than one repository. So for now, I'm just going to put everything in this core repository. So now let me find this here. paste in the URL. That'll be the source. Oh, and I just realized actually I'm looking at the wrong file. I want to do glibc, not gcc. So let me go back. I'll just create another folder under here. So, we're going to have glibc under G and also gcc under G. So I'll create this .pck file. So we have glibc package. I'll just copy this, paste it over into gcc. So let's see, going back to our glibc.pck file, it's going to be glibc, version will be 2.33, that's what we got there. And let's see, we do need a patch file, so that's an extra file that we need to download. So in addition to our regular glibc source file, we want to download a patch file as well. So that'll be considered an extra. So we'll have a section deps. This is going to be an array. mk deps, which is going to be another array. And extras, and that's an array. So extras contains files that need to be downloaded in addition to the source. And let's see, so we have the patch there, it needs to be downloaded. And I'd suggest you don't actually use the Linux from scratch URL for this. Maybe just upload the patches to your own server, or even in GitLab or GitHub, and just do them there. We also need this tz data file. That's another one of these files we need to download. So we'll add that to our extras. And okay. Alright, and deps is for any dependency packages, so if you had any other specific package, you'd put their names there. And let's get the sources, the correct sources. There we go. Okay, and let's see. We don't really have any dependencies for this, or any make dependencies. Make dependencies would be things you need to have installed on your build system in order to actually build it. So, but you don't want to necessarily install them on a client system or a host, the person installing. So, for instance, maybe CMake or rustc you might need to build a certain package. You'd put those in here, and they wouldn't get installed when the user installs the glibc package, for instance. But we don't really have any dependencies for this one. Let's see, so let's go back up to here, and I think that's going to be the full structure for the YAML document for our .pck file. Now let's go in and create some initial we'll create some initial code to map to this. Yeah, we have our GCC file here as well, which we can finish doing that one later, so I'll get back to that. Now, if we go to our build file, let's take this build file is going to essentially be where we run all of the build scripts. So that glibc file will be in a directory under that, so that should be fine as is. We make the directory build and run configure. And let's see, and next we're just going to run make, and then a couple other things here. So we'll do make, and you can make check if you want. Again, you probably should do it in a real distribution. In my little one here, I'm not going to bother with it. So this is a little sed script we need to run to fix something in our partial build environment that we have currently. And this touch etc ld so.conf I don't think we'll need. That was just for warnings. So let's run make install, but actually instead of just make install, we're going to do a destdir install, we're going to use this variable $p. That's where we're going to set up our packaging directories. So we'll have $p as our packaging. And that'll be set by the actual package manager that runs these scripts. So now all this other stuff, some of these things we can actually, you could either put these in the install script, but since this is referencing a local file from the source, I'm just going to put in a $p so in our package script, and I want to make sure that that directory exists too, so make sure $p/etc exists before we copy there. Alright, then I'm going to run these install commands. And now install has this -d, so you don't need to create the directories already. It'll enforce that those directories get created. And now let's go back here with this directory. I think we want to make that, we can create that again either place, but I'm just going to put it here. And we want to put $p before the directory because we want it to be in our package. And now all these locale defs, these will actually need to run after we do the install process. So, and you can pick whichever of these languages you want. I'm pretty much just going to stick with the POSIX and then the English US ones. Okay, and so this TZ data, we're going to need to be able to extract that. So we'll have to copy that into our install data folder. So let's see, copy, and again we need to do 2 back because we're in the build folder, subfolder, so we're going to copy that to $p.install, because when the package manager actually runs this build part, it's going to move the .install directory into our package folder. So I'll take this first one, locale def, the one with POSIX. Any specific languages you want, go ahead and pick them out. You could put all of them in there if you really want to. I'm just going to stick with the English US ones, but it's up to you. Let's see, and now we need to, yeah, you can run this and it'll actually install everything, but I'm not going to do that. But you'll again need to use the destdir for that too. So let's go back to here. And we have our TZ data. That's going to be in our .install folder, which is the same folder as this script. So we're just going to run tar-xf and TZ data, and then we're going to run pretty much this code all here from zone info down to unset zone info. It's making the directories, and then it's going to for loop through each of these different sections and run the ZIC program. So this pretty much installs all this time zone data. And then copies it all to the zone info, which is user share zone info, and then just unsets that variable that it set. So let's just copy this. And let's see, next we're going to just add some echo statements here. Setting time zone data. And then we're going to actually run that TZ select script here. So let me show you that. So TZ select, this is how you let the user select what time zone they want to use. So let me just run it in a console and I'll show you what it looks like. So TZ select, that's going to prompt you what your continent is basically, or the area. So if I say the Americas, and I say 49 for US, so I enter 49, Then I'll do 11 for central most areas. And then, you sure you want to pick it? Yes, 1 for yes. And you see it's got America, Chicago as my selected time zone. So one thing you can do is actually put this call in a variable. So if I say tz equals $tz select, then I again run this 249 11 1. Now if I echo tz, you can see it's got just America Chicago. So what I'm going to do is just run that script inside my install script. That's going to prompt the user. So let's see, tz select, and whatever they entered is going to be in tz. For now, we're just going to assume they said yes at the end and not worry about no. So then we're going to want to link this zone info $tz to etc local time. And let's see, I think we have one more thing we got to do. So we did that. That's the link. Yeah, we want to add this ld.so.conf. There's a couple configuration things we need to add. So this is basically for adding extra directories that you want your operating system to load dynamic libraries from. Also, I want to use the ld.so.conf.d folder as well, so I'm going to, if desired, you can add that. You don't need to, but I usually do. I'm just going to, instead of running this cat, I'm just going to append it inside here. Okay, so you can run cat, greater than, but I'm not going to do that. Instead, I'm just going to do this, and I'll just make this directory. And remember, we're inside the install script, so we don't want to use $p here, because this is actually going to run on that user's system. Hope that makes sense to you. So, and there's one other file, this ns-switch. It's needed to make sure that glibc works correctly in a networked environment, which pretty much everybody is running it in a networked environment. And I think that's going to be it for our install script. Let's see, so we have our install script, our build, which has all the things needed to build it, and then our package. So, and then this is going to get run by the package manager when we run it to actually build a package instead of install a package. There's a couple other fields I want to add here. Let's say is group false, because we might want to have one that's a group that just all it is just dependencies. And in some cases those will or won't have like a source package that gets downloaded with it. Let's see, you could add other ones as well, like a maintainer, like you say LLD is the maintainer of this, or I'm not going to do that one, but you could pretty much put anything you want in here. You just want to follow the YAML format. And if you're not familiar with that, then there's plenty of YouTube videos and information on the web on the YAML format. It's really simple, actually. If you're doing this kind of thing, you should be able to pick up on YAML, no problem. Okay, so let's go into these directories, and we'll start creating some things like include. We'll have a common.h. So we'll have a package.h. This is where we're going to put structures, and we also have one for putting common things. And I want to use this. I actually moved things around here. So I created a package.c and a common.c, put those in shared, and under include I created a LLDOS, so LLDOS package. So now that we can actually reference things like this instead. Sorry that I jumped you, but I had a bunch of coding that I went back and forth on, so in order to make things quicker, I just kind of jumped ahead into this. Alright, so in our common.h, you can do pragma once. I'm going to do include. So I'm going to do stdint. Let's see, std bool. These are the ones that I use all the time. And I'm just going to put some simple type defs. So for type def for U32, we'll do one for U64 as well. And let's see, 16 and 8 as well. And oh, we messed this up. That's not 34. It should be 32. It's not any 34-bit numbers there. Okay, so those will be our main defines, or not defines, but type defs. So let's see if we go to our package. That's going to use package.h. So let's go to package.h, and I'm going to copy this structure. Just going to paste it in a comment so we can easily reference it. We'll say structure for YAML document. So now let's create a type def struct. And I can't spell type def. Okay, this will be called a, let's call it the LLD package, or maybe LLD OS package. Okay, so this is essentially going to have, you know, a field for each of those variables. So I have the char pointer name, char pointer version. We'll do the repo as well. And just to make it easier, we're going to do one for, let's see, source. And we'll have a bool for is group, and then a bool for no source. I don't know if I like that name, but let's see. So then we're going to have these dependencies, make dependencies, and extras are going to be arrays, but I don't want to use an array. I want it to be easily growable, so I'll just use like a linked list. And if you're not familiar with linked lists, there's plenty of information out there on them. So I'm going to name my linked list stir list. Alright. And then we need to actually create this linked list. I'll put it in the common area. So this is essentially going to be a list of strings. So type def struct stir list, and it's going to have a char pointer stir, and then a struct stir list underscore pointer next. So that's our simple, that'll point to the next element in the linked list. It's our simple little linked list structure. Again, I could get really complicated with this, but I want to make things as simple as possible. It's also one of the reasons I don't use C++ in these tutorials. I just want it to be basic and simple so everybody can understand what's going on. Okay, and I think that's actually enough for now. I want to keep these videos short, like I said, and this pretty much got you to the very beginning of it, setting up, figuring out what the structure of the packages are going to be, and setting up the initial, you know, header files for this utility that's going to make our packages. So I hope you enjoyed this video. In the next video we're going to start probably actually writing some of the code for this thing to create our packages. So if you liked this video, again, like, comment, subscribe, all that stuff, and thanks for watching.